It's my great pleasure to introduce James Pustejovsky. He went to MIT for his undergraduate degree and did math and linguistics. He did Fulbright in Germany in classical linguistics, and went to the University of Massachusetts at Amherst to do his PhD in linguistics. And then did a postdoc with Wendy Leonard and David McDonald in computer science. And he's now a professor of computer science at Brno University. I've known James for about 20 years. His interest is lexical semantics, and he's responsible for the theory of the generative lexicon. But I think he has a very unique perspective in our field, because at the same time that his interest has been in representing meaning, he's never taken his eye off of the big picture like some of us have. He also has always led a big team doing an application. So he was involved with our laboratory in the Tipster project. He's worked in the Equate project recently doing question answering. He's had his own company called Lingo Motors. He's been involved in huge state-funded biomedical research. So he really has a very unique perspective on properties that are important if we're ever going for the big representation of text. He's uniquely tall, and maybe unique in this room, because other than Fred Jelinek, I think they're the only two with a Wikipedia entry that they may not be aware of. It's my great pleasure.
Thanks, Louise. A little too gracious introduction, but I'll take it when I can get it. What I want to talk about today is something which I've been thinking about for a while, and have kind of been sort of stimulated to talk about it more structurally and formally by a talk that Ed Hovey gave at LREC, a keynote on the role of annotation in our field, particularly something that he frames and other people are also starting to frame as annotation science, or the science of annotation. And so what I want to talk about today to this community, the major issue is, what is the goal of annotation in computational linguistics generally. I'm going to review some methodological assumptions which I think we should pursue, and believe that they guide my own research and my group's work, and that a case study of timeML will be an example of these methodological assumptions. So I'll talk about that as a case study. Then I'll get to the inadequacies of a specific individual framework or theory, and why, in order to capture the larger picture, reading, story understanding, and other things such as Ed was talking about in the first address on Tuesday, why we need to actually create a unified linguistic annotation of some sort. And then I'll conclude. So what I mean by annotation is, specifically for the context of today, I'm going to focus on mostly semantic annotation. Now, we're familiar with annotation in the context of features that we'll use for any number of applications in computational linguistics: part of speech tagging, named entity tagging, for creating labels and tags for various types of document retrieval and clustering. Let's just focus on a couple here, just to give you a sense of where I'm coming from. I'd like to look at examples of semantic annotation, such as predicates or verbs, and their sort of is that okay? Looks like a little bit of distortion. Is it? I don't know if that's, as long as it's readable. Predicates and their arguments. Here, essentially classic named thematic roles or case roles to a predicate. That's a particular kind of semantic annotation task. Anaphors and antecedents, both for objects, entities, as well as for, let's say, facts, propositions, and events. They're all distinct types of anaphor-antecedent links. The annotation effort that goes into creating a corpus associated with this is, in fact, distinct from those related to predicates and arguments. Acronyms and abbreviations and their long forms, such as in bioinformatics, you have an acronym or an abbreviation, and then the long form or the interpretation of what it is. This is a huge area, something I've done work on in the past. And then semantic typing of entities to predicates, such as what actually is the type of an argument that a predicate selects. For example, in work that Patrick's been doing, Patrick Hanks, the man fired the gun. This is distinct from case role assignment. So these are different types of annotations. So I'd like to make a couple of points. One, semantic annotation, I believe, is critical for robust language understanding, and I'll try to argue why. Summarization, question answering, text inferencing, reading, as Ed was talking about, and story understanding more broadly are just some of the examples, major examples in the field right now, mostly pursued through statistical techniques. But I believe semantic annotation is absolutely necessary in order to get to performance that is acceptable. The annotation schemata that we're adopting, I believe, should focus on single coherent themes. That different linguistic phenomena, such as the ones I just mentioned, and others, including such as maybe even WH binding or other types of linguistic effects that you can model, should be annotated separately over the same corpus. That's something I'm going to argue for. And it will guide our research. Annotations, however, if that's the case, then have to be consistent with each other, and that requires a unification and a merging of these multiple annotations in order to come up with an annotation of a specific corpus that is useful for training and then testing applications that are more robust than any particular single annotation scheme would give rise to. So hence, I think the takeaway point I'd like to push is that the annotate, train, and test model, which is part of our field, advances linguistic theory in a way that we don't really appreciate, and in fact isn't necessarily even employed necessarily. Theories need testing to evaluate the coverage and the predictive force. And semantic theories in particular are too complex currently to develop without this model of annotate, train, and test. I think my computer just went to sleep. Okay. So the methodological assumptions that we make as a discipline, and I'm just going to make more explicit, this is my perspective, you may not share this completely, is that we have an annotation scheme to do some sort of annotation, a tagging of a text for subsequent purposes of training algorithms and testing them. This assumes a specific feature set. Now, that feature set is actually an encoding of specific structural descriptions and properties of input data. Now, these structural descriptions are themselves theoretically informed attributes which are derived from empirical observations over the data. Sometimes empirical observations and the theoretical constructions over those observations that go back 70 years, let's say. In the case of the structural properties that we use for annotating for finite state parsing, for example, named entity recognition, the tag set, the phrase set, the types of dependencies you get, such in dependency grammar, these observations go back 40, 50 years. It's not just a feature. It's encapsulating theory. So what you really have is this chain of development. Theory gives rise to this description, which is encodable as features, which themselves are still quite transparently related to the theory. But the annotation is not necessarily itself such a reflection of the theory itself, but if you look at the chain, it is. Now, what I want to argue is that when you do an annotation and put it into that annotate, train, test cycle, the cycle means that that's going to influence your theory. And the theory will change. That's the goal. That's what you want in terms of creating something that we could be proud of as a type of normal scientific behavior in the way that we actually create models of language, which is not part of the pure algebraic theoretical approach, of the classic Chomskyan model, where there is no such integration with real data and the modification of theories from annotation. So to test this example, this methodology, I want to look first at the issue of temporal awareness or temporal information that's associated with language. In particular, I'm going to look at textual input. But the same remarks would go for speech, but that adds a new dimension of complexity. So you take a text such as this Associated Press newswire from '90. This is Gulf War I, with Bush won and Saddam won. And you look at this text, and in order to be able to ask questions, to answer questions that you may have about the events that are going on here, what events actually happened, what events happened before other events, what was the state of, let's say, a particular force relative to another force, or when something happened and some sort of negotiations were being sought. What was the situation on the ground in Iraq, for example? And it's impossible to answer such questions and make such inferences without understanding the relationship that, for example, here in this text, are actually quite explicit, and we understand as readers of a language, of our native language, or if you understand English. But it's quite different than just spotting named entities that would be events, such as, I know a quarantine is an event. Well, here, I see that I'm actually extending a quarantine, and extending is going to essentially give us the information that this quarantine exists. So it's a kind of presupposition being imposed by that particular predicate. One example. So there are events. There are events that didn't happen. There are events that we would like to happen. There are events that happened that we didn't want to happen. And all of these things have different modal status. And they impact the way you would summarize a text. They impact how you would reason about it, how you would answer questions about it. So one thing that we've developed in the context initially of a question answering effort in the United States funded by ARDA, A-R-D-A, starting in 2002, is a time markup language that I call timeML, starting back in 2002. And this was a markup language that we wanted to mark up not just time expressions, like the ACE-based timex2, or not just events, such as just predicates by themselves, but time expressions, anything that could be considered an eventuality, the relations between them, and then such as temporal relations, other relations. And then to put this into, this is essentially to try to encode the best feature set from the theoretical observations that have been made about tense, aspect, temporal relations, temporal ordering for the last 40 years in the field, and then create a specification that we could use to annotate text and then train and create automatic annotators. So this is an instantiation of that chain that I was outlining in the first couple of slides. So, to wit, timeML 1.2 is the current instantiation of this, which is always in flux, and it essentially allows us to incorporate all those features that I just outlined that I'll go into some detail about, and in fact has just recently been adopted at the Beijing meeting of the ISO, the International Standards Organization, as actually an ISO standard for representing events and times, something we're quite proud of because it's quite an international effort that we've put into that. So the goal here is to show how theory has turned into a more tangible description that we can put into features that are then amenable to the computational cycle that we know and love and has a certain kind of currency in the current field, namely annotation, train, and test. So with that in mind, let me just tell you what timeML essentially tries to capture in terms of its feature set. I'll go into the recognizers for those. I'll go into some specific problems. And then I will talk about the successes, what we can do, and then I'll talk about what is near to impossible given our current understanding of discourse models and semantics. And then I'll go into how we need unified